The English scientist Cavendish measured the density of the Earth several times using a torsion balance. The variable recorded was the density of the Earth as a multiple of the density of water. And here are the 29 measurements that he took. We want to show it graphically in a stem plot. So in the past, we've drawn our stem plots vertically, so you draw the bar vertically and then write horizontally all the numbers. You can do it that way. You can do it also horizontally. So this time I'm going to do it horizontally, which is going to be kind of difficult for me to write on the whiteboard, but I'm just going to show you can do it either way. It doesn't really matter. People don't care stem plots one way or the other. So I just thought for something different, we'll do it this way. So as I do these stem plots, what I'm going to do is I'm going to make the horizontal bar on the bottom side of it. I'm going to make it the whole number, and the top part of it, I'm going to make it the decimal. So for example, my smallest value looks like 4.88 right here, third number in. So I'm going to put down a 4. Maybe not. How many values are there? 3, 6, 9, 11, 22, 25, 29. That might be too many going across. Okay, so maybe I'll go with 2 digits. So I'll go 48 and then 8. And what this is representing is 4.88. And I'll just continue to do that so we can kind of see what's going on. So then if I list 49, is there anything in the 49 category? 4.9 anything? Nothing in 4.9. No. All right, how about 5.0 something? 07? All right, so I'm going to give you a little bit of time. I want you to fill in the rest of this using this methodology for a stem and leaf. Okay, so on the note packet now, we wrote our stem and leaf horizontally instead of vertically. It doesn't matter which way you do it. It just seemed like space-wise for me that I would benefit from putting it horizontally, so that's why I did that. As you look at the shape of this graph, and you talk about the socks, what you'll notice is it has a slight tail maybe to the left compared to the right, but in general this distribution is roughly symmetric. So the shape is roughly symmetric. It looks like the center is somewhere around 5.4, but we don't know for sure, so we can use our lists to take care of that in a little bit. You can talk about the spread going from 4.88 to 5.85. You could talk about the range, of course, by subtracting those two numbers and finding out that value. And so as you talk about the shape, center, and spread, I would say the shape is roughly symmetric. I would say that our center is somewhere around
5.46.
Oh, it is?
Yeah.
5 point, you found it already?
The median, yeah. And
Okay, 5.46, that's the median.
Yeah, the mean's 5.448.
And the mean is equal to 5.448.
Yeah.
Thank you. I can look at the spread. So the spread is from 4.88 to 5.85. And when we talk about the outliers, we could check the box plot and you would see that there are no outliers. And the way that you do that is, of course, you just enter all this data as we did while we were offline here. And you can look at your calculator. And so when you look at your calculator, you could graph this data. And as you look at your modified box and whisker, you'll see that there are no outliers. Now, if you were to see outliers, you'd see, depending on what marking you chose, a little box, a dot, or the plus sign on either end of the whisker. One of the things to be very careful about is a lot of people think that the whiskers are the minimum and the maximum. And generally, that's true. However, if there's an outlier, wherever the smallest value is, that is your minimum. Whatever the largest value, it is your maximum, whether it's an outlier or not. So usually the whiskers are the min and the max, but not always. Not if there's an outlier. So don't forget about that in case you ever end up with an outlier. if we were only looking at our stem and leaf, I guess I would have to estimate that since the most dense group of numbers falls between 5.2 and 5.6, I would estimate that my density would somewhere maybe around 5.4 something, just from looking at the stem and leaf. So if I had to purely guess about my density, I would say that it's around 5.45 maybe, and that's because that's the balancing point of my stem and leaf. So as you look at it, and you look at where the vast majority of numbers are grouped, we talked about between 5.2 and 5.68, and in the middle of there is somewhere in the 5.4s, in the middle of that is 5.45. And so that's where I would estimate that the density of the Earth was. As we heard, as we were looking at our list, and we did a one variable stat calculation, the median was 5.46, we're within 1/100th, and the mean is 5.45 to 2 decimal places, and if we go even farther, we were within 2 thousandths. So it's a pretty good estimate of where that center is based on just the stem and leaf. Finishing up with the description, but I kind of wanted to put up the information graphically at least. So they asked us to compare the distributions graphically and numerically. If I were to draw, I think the way that I would graphically represent this is I would do box and whisker. And so it looks like the smallest value that I see is somewhere right around 30, right? 29? 22?
29, yeah, you're right.
Okay, so I'm going to go with 30 right here, and then 40, 50, 60, 70, 80, and 90. And if I was talking about the American League, which I'll do in red, it looks like it ranges from a minimum value around 35 and a Q1 somewhere around 50, close to 50, right? 49. Okay, median almost 60. And we'll talk about these exact numbers in a little bit. Q3 at about 68. And then a maximum of 77. So my box and whisker looks something like this. And again, I'll find these exact data points and write them down shortly. And this was my American League. And then the National League, if I did the same kind of thing, what you find out when you graph it is that there are a couple of outliers. Right down here. And then the end of your whisker is right around 40. And you have a Q1 at 46. You have a median at 60 or 50? 50? 50, somewhere around there. Q3 at 55. And a max at 67. So it looks something like this. And then you can go into your calculator, and that's what I'm going to talk about next, because you kind of need to know how to do this. So as I look at comparing these two things, from the box and whisker at least, you can see that the American League is pretty symmetrical. Not a big change there. The National League actually looks like its tail is skewed to the right, but there are a couple of outliers on the low end that you probably should discuss. You can see that from your modified box plot. If you want to use, this is a graphical representation. If you want to do a numerical representation, what you do in your calculators after you enter these in your lists, to do list 1 data, you would go stat, calc, enter, enter. And the reason you hit enter twice is because your calculator defaults to list 1. So anytime you put something in list 1, whatever you're doing, it's automatically going to pull anything out of list 1. And from here I can see that my mean is 56.93 roughly. I can see that my number of data points is 14. If I want to talk about standard deviation, it's 12.69. I can find out that my minimum is 35, my Q1 is 49, median is 57.5, Q3 is 68, max is 77. So no big deal for that. But when you have two different lists that you want to talk about individually, the way that you do the second list is you're going to go stat, calc, enter. But this time, I don't want it to use list 1. So in order to talk about list 2, I do second, number 2. And I hit enter. And this will now give me my data for list number 2. So your mean, your median, your Q1s, 3s, mins, maxes, and then you can put those in a list. So I was going to write them down on the graphs, but since they said to also do it numerically, I guess what I would do is I would write these down as a list or maybe in a chart even. So for example, I could talk about, we had the American League, I'll do that in red, and then we had the National League, and I'll do that in blue. And we talked about a few different things. So the things that we talked about were, we could talk about the number of data points, we could talk about the mean, we could talk about the standard deviation, we could talk about the min, we could talk about the Q1, the median, Q3, and the max. And then we could list those for each of the things, and so the reader will know exactly what we're doing. So for the American League, that was 14 data points. And I don't know if you remember, but in our crunchy and our creamy peanut butter, they didn't have the same number of data points, which is okay when you're comparing. But it's also nice to list that you have the same amount of data points. And then this was, for the mean was 56.93 is what I got. Standard deviation of 12.69. Our min was 35. Don't forget if there are outliers that you have to look at the outliers for the min. Q1 was 49, 57.5, 68, and 77. And then in the National League, if I'm writing those down, 14 again for our data points, 50.14, 11.13, 29, 46, 50.5, 55, and 67. So now we've written down all the different pieces of information numerically. The last thing that they ask is to write a few sentences about what you've found. Okay, so you can look at your picture, and you can look at your data, and you can draw some conclusions. So, for example, you might say something like, the data suggests that the number of home runs is somewhat less in the National League. So you look at your X bar, 56 in the American League, almost 57, 50 in the National. So that's something important to notice. All 5 numbers in our 5-number summary and the mean are less for the National League teams than they are for the American League. So as we look at our picture from up above, what that's saying is, look at the outliers in the National League, far below where the American League is. Look at the Q1 for the National League, less than the Q1 for the American League. Median, less than the American League. Q3, less. Everything is less. The whole graph has been shifted to the left. So that's important to notice. However, there's more variability in the American League teams. And what that means is from small to big, there's a greater range. So even though everything in the National League is shifted left, there's more spread in the National League. Or sorry, in the American League. Both of the distributions are roughly symmetric. Remember we talked about the tail over here looking like it was skewed to the right for the National League in the blue? However, if you consider the fact of your outliers are way over here and look where the middle is, it looks roughly symmetric because of the outliers. If there weren't the outliers, you could say it was skewed right. And then the American League team doesn't have any outliers. The National League has 2 outliers. And I guess I would name what the outliers were. So for the National League, the 2 outliers were 29 and 31. Yep. And I would just name them.